Good morning, USA. I got a feeling that it's gonna be a wonderful day. The sun in the sky has a smile on its face and is shining its face to the American flag. Although it's safe to say, good morning, USA. Good morning, everyone. Did you like my intro song today? Hi, Haley. Hi, Player 2 Studio. I see that you've been waiting, Ryan and Mike Blackcat. Thank you so much for joining today. Due to copyright issues, I am unfortunately not able to play the original song. That's why I went forth and gave you my singing version. Hope that is not copyrighted. And as always, we have our wonderful guest, August. Hi, August.
Hey, how's it going?
For those of you joining for the first time, August is our interactive engineer and the creative mind behind Microjam. How are you guys all doing today? Hello there. Hi, I see a couple more people on the chat. Excited to have you here. I would love to pronounce your name. I do not read Arabic, unfortunately, but I see you. Welcome, everyone. Let's start out with a small yet important question. How was your weekend, August?
It was great. Yeah, had a great time.
Sounds good. How do I change a texture of screen image when it's tapped, just like the soundboard effect?
Change a texture of screen image when it's tapped. Well, let's create a screen image. Now we have our screen image. Image tap. So we want to use screen image tap for screen images. And there's a couple different screen tap. So this is like the simplified node. You can also use, let's see, finger touch 1 point. So these are your options for touching. And then for the screen image, you could get image if you want to have a reference. Or my favorite thing about the newer versions is this object picker. You can just choose your screen image here. The huge benefit of that is that anytime you click here, you can see which object is input there, which is really nice, especially if you have a lot of same named objects while you're prototyping. So this screen image tap, actually, you don't need the tap nodes. Sorry, I totally forgot. It has its own. So what you would want to do is your texture here, you would set texture. So you'd only have to connect these two nodes, and then you would figure out what texture you want to set it to. So I'm assuming you have some other texture, maybe this other default texture. When you tap it, it changes to that. Let's reset it and just see. There's this empty space, and you can see in the 2D scene view this empty space here. What if I click that? Because it's not rendered there, but it is pulled to full screen and set to stretch mode fit. If I click there, it doesn't actually tap it. If you want it to be tappable in the whole bounds, say you're prototyping and you just want a rectangular area, you can set this to stretch. And then when you click, all of the bounds for your 2D object will be that clickable range. So yeah, that's just a full answer. All right. Well, so that's collision. There's a lot of different answers for a lot of different situations. So if you have 2D and 3D objects, you'll basically want to choose one. You don't want to make one function that collides with 2D and 3D objects because that just gets chaotic. So what you would do is you would make like maybe you would make a subgraph that checks collision between 2D in like 2D space, and then you constantly convert your 3D objects to fit into 2D space. I can show you. This might be a little bit more of a complicated one, but not too complicated. So there's a lot of different types of collision. We could go with radial collision, or like assuming everything is a circle. But that won't really work great when the corners of a square collide, for instance. But we'll just go with that for now. So I'll just put these here for visualization purposes. If we were to say that they're at the root of the hierarchy, so they're not being like scaled or repositioned by a parent, that helps us out a lot. So we can just make that assumption, and then we'll say get position of each of them. And then we'll say that the size is their radius. So just kind of assume that they're circles, right? And then we basically have everything we need. I think I might have talked about this same kind of question in an office hour before as well. So the position, we'll just say the distance between the two objects. So this is their positions. So this is like the distance between them. And then we also want to find I guess we want to add the sizes of these. And for this, we're going to assume that they're circles, right? Because that simplifies the problem. And you can find a more complex problem by extrapolating this and looking up solutions online. But basically, we'll just say, let's take the size and just say it's the radius. In which case, we'll just choose X. So then we're going to add the radius of each of these. So imagine a line going from the center of these towards each other. Notice that if both of the radiuses are exactly the same distance between them, then they'll hit this sort of threshold value. So let's add these. And now we're going to compare these. And then we'll just use a greater than. So if the distance, or if the radiuses of these circles are greater than the distance between them, if that makes sense, I would think about that phrase a lot if that doesn't quite make sense to you yet, then that would mean that they're touching. If two circles are closer than both of their radiuses added together, then they would be overlapping, essentially. So if we want to check this, we can just put an update here, and then we could put it, I guess with the if, kind of just need to look at which one is outputting. So for this, the radiuses are actually, so yeah, like the circle would be, it actually doesn't seem quite right. But if we pull this away, it still says they're colliding. If their radiuses are greater, oh, they're in stretch mode. Okay, the logic is normal. I just have to figure out why. So the distance between them is 432 between their centers. Oh, I'm sorry. It's the size. The size is the whole diameter, not the circumference, or not the radius. So you have to divide. Sorry. Or just multiply by 0.5, I think, is more efficient, but divide by 2 is the same thing for this experiment. And then this should be correct. So now we'll see that this blue dot on this output if statement, that will tell us when they're colliding, which, remember, they're circles, so it actually works better if they're side by side because the corners can't collide. So once it gets right here, they're right on the border of being able to collide, and then now they're colliding. You can see the if statement lights up. And then right at the edge, just barely not colliding, and now they're colliding. And so that'll be how you add some logic to. Let's just say this one disappears when it collides. Set visibility, just to make it more visual for the people who aren't used to reading in here in the visual scripting panel. So here we are. I'm going to turn off this magnet because it's kind of making it hard. So when it collides, it destroys it.
It's gone.
Okay, cool. Yeah, that's kind of a complex one because like that's just one of many solutions. That's like a classic one though, just assuming everything's a circle. So hopefully that helps.
Sounds good. Hope that was helpful. Next question by Fam. Hey August, can you please show us a way to create a smoother animation with transit by time and lerp nodes? Lerp nodes is actually one of my favorite nodes of all time because it really allows for that smooth motion and I love it. I think more people should use it in their effects.
Yeah. How to make smoother transitions. All right. I'll crack open the easing curve library. And then you guys can see how it's done and hopefully make some of your own. Let's see, transit by time. I use transit by time sometimes, but for most transitions, I have a timer and then I have a lerp node instead of this transit by time. Transit by time is great because it combines those two in simple situations. For instance, Vec3, this is your lerp node, really, because your lerp node is just going to convert a 0 to 1 normalized value to a from and a to value. So really, the lerp node is in here. This is a lerp combined with a timer, realistically. And then it also has this interpolator, ease in, ease out. These are how you make the smooth transitions. So this is kind of an all built-in nice little thing. What I usually do is I'll usually basically rebuild this with a timer and a lerp node. And then I'll use an easing curve. And I think you guys are going to be pretty happy and surprised by the result of this, because where there's these easing curves here, I think it's a great selection for just making something smoother, but sometimes you want some interesting behavior. So let's see. Let's just connect the screen tap to this so we can control it. I always love prototyping with screen taps, so you can just tap and see what a specific thing is doing. We'll just say it lasts 1 second. And then you have these three numbers. You have progress, which is what I usually use for this because it's a normalized 0 to 1, just like we were talking about before, and you convert it to whatever you need here. So let's add a cube to the scene, and we'll control that cube. I recently made an effect where I shrunk down the scale in like a goofy, cartoony way by using a easing curve. So right now with lerp, there's not too much you could do. It would be very linear if you said go from 1, 1, 1. Oops. Okay. To, let's say we want to shrink it down to 0.2, 0.2. There we go. So we can put that in. And then I would use on the timer or the, here, we'll just keep this one up for reference since you mentioned it. They both have essentially the same events. They might be named a little differently, but they're the same. So tick and stay are going to be the same. That's just an event that happens for every single frame that the timer is running. So when I tap, it's going to linearly shrink down like that. And I'll turn off these other things. So that doesn't look too interesting, right? It looks kind of interesting, depending on what you think is interesting. But let's add an easing curve in. And I've just tried to create a few of these recently for some different projects, and I really like how this one looks as like a funny kind of look. So instead of this lerp, which is linear interpolation, we'll use an easing curve, which is like kind of a curved interpolation. And I'll put this here, and our lerp value will still probably be useful here because we still want it to go to specific values. This interpolation that we're doing here is we're basically just curving that normalized 0 to 1. So we're still feeding it into a lerp to get our start and end values, but it's going to get to those values a little differently. So now if I tap, kind of, I don't know if you can see that easily, but it kind of like bounces. I'll make it a little bigger so we can see. And I'll make it bigger just by parenting it to something and scaling it up. So I don't know. I think that is very like interactive and fun looking. But to do this, it's not too complicated. You can just Google search easing curves, and there's tons of examples. And usually websites will show you the equation that they would write to create this. And it's a little different in different languages, like how to create things, or some things like are harder to create. Just find like an easing curve that you like the look of it, and then you just map it out here. This one is literally just one equation. But sometimes they'll say like, if the normalized value is above 0.5, do this equation. If it's below, do this equation. So you have to write a few different equations and some sort of if statements or logic select nodes to choose which equation to use at which time. And then I just put the equation that I grabbed from online right here. And you can see this is what it looks like. This C4 was just a constant value, so I just plugged that in as a constant value. And then it looks something like that. So that's where you would put an easing curve if you ever add one to a project, and it makes it go from that linear look to just like this bounce. Or, there's tons of easing curves to make it look different ways. So look into that, and hopefully that helps.
Thank you for that amazing lesson, August. Where can people find easing curve if you haven't mentioned it already?
I mean, I would just Google search, and there's tons of forums and websites. I don't know if I should say endorse any specific websites, but can I?
Yeah, go for it.
All right. It's just the first one that comes up when I Google easing curves. It's like easingcurves.net or something.
Very nice. So here you can find the subgraphs for that you used.
No. That's just a random website that shows you all kinds of easing curves with with functions of how to build them.
Yeah. Okay, that's good. Thank you for that helpful resource. Oh,
Yeah, make sure to look into the keyboard microjam. If you look on the guide on the website, it goes in detail about easing curves, and it shares, I think it gives one easing curve subgraph in that project that you can look at as well.
Sounds good. So if you don't know how to create an easing curve, go create our microjam project. Joe, there's a funny comment in our chat. Joe says, "OMG, is August using the bald effect or question mark question mark?" So it is very realistic, I would say. Joe was very surprised, but then he saw your photo in the bottom left corner and he's like, oh, gotcha, got you. But you look good bald.
Everybody convinced me to do it last time,
Yeah,
so I
I
just
know.
went for it.
So many people are listing their favorite nodes in the chat. Player 2 Studios says Transit by Time is my fave, and he also says he loves the Remap node. Can you tell me a little bit more about the Remap node?
Yeah, sure. And then in the chat, if anybody wants to say what 6 nodes would you build if you had to bring 6 nodes to defeat the Elite Four in Pokemon? Uh,
We should do
uh,
Pokemon Battle Effect, but instead of Pokemon, it's just nodes. So it's like Remap, Scale, Tap to get visibility. Get visibility is the go though. Like that's my favorite. Like I can't build anything without get visibility. And the new interactions that we added makes it super easy for anyone to use get visibility. So if you haven't already, go check out interactions.
oh yeah, nice. Yeah, I haven't played around with them too much, but they seem pretty powerful. So the remap node, I mean, in a way, it's almost like lerp. It's like similar, uh, but in its current state, it just works for individual numbers. uh, I use it sometimes in place of when you need to do something that's kind of like clamping, but you also want to interpolate it between some values. One really useful thing, let's see, maybe I can find some way to do this with this example. So now our normalized value is going to come in at 0 to 1, we'll say. And this gives us a range of like, where is the incoming value going to be? And then the outgoing value, we would say maybe is, well, we have it at 0.2 here. And then you can just pop that in. Oh, well, what did I do? Oh yeah, you wouldn't use the lerp node. You'd use this in place of the lerp node. So basically, you're just going to let the data convert node come in here and data convert, because you do want all 3 of the values to actually be X, Y, and Z in this case. So then when this value is 0, the output value is 0. And when this input value is 1, your output value is 0.2. I'll usually clamp it just because there's not many cases where I want any outside values to be affecting it. In this case, only 0 to 1 will be input. There's not really a way to break it so that your value is outside of that 0 to 1 range. Some easing curves will exit out of the 0 to 1 range sometimes, so keep that in mind. But yeah, so if we turn this back on, we can see it does the same thing. It's a little fast though, but I guess that's how it was before. So with this remap, you can actually flip it, and you could say, when this is 0, I want it to be 0.2, and what the output max, when it's 1, it'll go back to 1. So in this way, this is a very easy way to flip your values so that it springs up big in the same way that it went small. So that's one really cool thing about Remap, is that you can flip the values and it'll kind of flip the interpolation. So as 0 goes to 1, 0.2 goes to 1. Oh, I guess I flipped it before. But yeah, so you can make it so that when your input value is getting bigger, your output value is getting smaller if you want to. Or as your input value is going up, your input value is like going into negative values. And so that can be pretty useful. Sometimes you can kind of do that with the lerp node in a way, but it takes more setup. So this is like a really nice, easy to use, very versatile node. That's pretty much what I use it for. And if you unclick this clamp, then it'll take that interpolation outside of this 0 to 1. So if you had -1, for instance, then you might get a -1 on the output, because it would be the opposite of this +1 output.
Sounds good. So clamp is just basically a node that keeps it within that range.
Clamp is an option that says if the input is below 0, then set it to 0. If
Mm-hmm.
the input is above 1, then say that it's 1.
Yeah, yeah. Thank you for that answer. Joe also shared a very good resource about different animation and videos of the interpretation settings that was in the Discord channel last year. So, if anybody has questions about the different modes of interpolation, you can find it in our Discord channel. You should be able to search for that. Joe commented, I forgot Remap exists. Just another day, I recreated the Remap logic all manually. Oh no. Yeah, there is a lot of nodes, so sometimes I forget like that a special nodes exist, and then I go in ahead and recreate it, and then I'm like, oh my god, I did all this work. But that's awesome. I hope it was a very good learning experience. Get to refresh on that knowledge. We all always know that you're a very talented AR artist. So, thumbs up. On to the next question. Um, so, is there a way? Is it possible to create an array with like scene objects and use like the index of the array to loop through using like for loop?
Yeah,
I
yeah,
guess
yeah.
I guess
Uh,
I have been always curious about continuous Snapchat and how to use continuous Snapchat. Do you think this is a good way to use it with, like combining it with the index array loop and then using the for loop with it?
um, I'm not sure. It really depends what you want to do. With the I wouldn't necessarily. So I think the most common usage of the moving snapshot or continuous snapshot node is kind of just like choosing an index of how old of a screenshot you want to use. So if
Mm-hmm.
you choose like a higher index, then that is like a snapshot that was taken like that many frames ago. So like an index of 10, it might be like a snapshot from 10 frames ago. So that's great for creating like effects where there's a video delay, and stuff like that. So that's really I think the original design reason for why it was made. But yeah, you totally can do a continuous snapshot, let it record a bunch of images, but just keep in mind that when you're looping through them every frame, yeah, there's tons of things you could do with that. But I I guess, do they want me to just say yes or no, or do they want me to show how to loop through an array? Or
Yeah, yeah, that would be helpful.
okay, um, let's turn off the extra stuff. Maybe we can duplicate these, and then uh, oh no, why are they? Okay, we'll just create these four. Um, get children scene objects. So the parent scene object is this 2D camera. Usually, I wouldn't suggest just using a camera as the parent object of things that you're trying to get as an array, but uh, we'll just do it for this one. I would usually just say create an empty holder object is what I like to do, because you don't ever want to move this camera, but you might want to move all the objects together. So then this comes out with an array here. So one really good piece of advice. This is what I always do with these get nodes, the get children, get component. They're very new, so you might not be super familiar with them, or familiar with them at all. But just connect Well, right now, I'm sorry. Sorry to say this. You should hopefully be able to connect a start node eventually, but I would just connect a start node with a wait node, just to make sure that it's not during the first frame. As long as it's not during this first start frame, currently, it will work. So it just has to be, the effect has to be fully loaded, and then you can ping this. It'll get from this parent that you selected, it'll get all the children and put them into an array. And then after the effect loads, there's not really currently any way in visual scripting to change what is parented to what or delete objects or anything like that. So this array, after the first time you grab it, it's not going to change. It's not going to be different. It's always going to give you the same objects. So don't ping this every frame with an update node, because you're going to be getting the same array of objects every single time you ping it. So then you have this array, right? So then maybe you want to get item from array. So get item from array. And for each of these, maybe you just want to do something. We'll pull the for loop in. The ancient for loop has been waiting for its time to shine. So we'll put an update, or we'll put a screen tap like I always love to do. So screen tap will trigger this, and I'm hearing somebody smashing a gumball machine. So one thing you can also do is pull your array into this array info node, which will just give you the length of the array. Okay, you can see that it processed and it's like, oh, it's 4. There's 4 of them. So that works there. And then I guess what do we want to do with these? Well, let's say that we want to change their color. How do you do that? We have the image here. We know how to add the set color node, but we have an array of them now. So what do we do with that? Well, you can use the get component. This is another one that stores its value, and then you don't need it again. But just for the sake of this, okay, cool. Now we're getting the object from our array, and then we're getting the screen image, or we're getting the image component from it. So that would be in the body, because the body is what is happening to each object. Next is just what happens once the for loop finishes looping through. So for here, we'll want to make sure that it's grabbing from the current index. Okay, now we have our image, and then we're going to say screen image. Image. Oh, set image. We're going to do set image, and then we're also going to do image info. So notice that we're kind of playing in this space where there's all these huge nodes. So now all of the things that you don't want to change, just connect them. And all of the things that you do want to change, don't connect them, and you can do some sort of thing. So what could we do to make this? What could we do to make this do something? Well, we could use the index to make it obvious what's happening. Maybe the index could, we could set that to the opacity. So yeah, just as a way to visualize what's happening. So we'll just divide by 4, since the max index is going to be 4. I guess it's going to be 3. Let's see. And then when I screen tap, all of them are 0. Okay. 4 by 4. So not sure why that would be. Let's make sure that, okay, if I screen tap now, opacity becomes 0. Okay, so all of them disappear here. Why is that? We're getting our scene object. We can see that this 4 works. The screen tap starts the for loop from 0 to 1. The first object is going to be 0. It will get the scene object. Once it has the scene object, oh, yeah, once it has that individual scene object, it will try to get the image component of the scene object. And once it has the image component, it will try to set the image. Oh, okay.
August, Joe's
Here.
mentioned feed the image info node.
Yeah, I saw that right as you were saying that. Okay. And now you can see as soon as I click, it'll do the for loop for its first time and grab the image, and you can see all of these values populate, which means that you're probably seeing the last one in the array. Thanks for the tip, by the way. And then if we feed this into opacity, we'll just see them. Each one in the array will have like a slightly higher opacity. So you can see this is 0, this
Oh
is
my
1,
god.
this is 2, this is 3. Yeah. So that's like probably not anything you would ever use a for loop for, but I think you usually have a more complex setup if you're using for loops and you're doing more complicated things. So this is like just something off the top of my head that is a little visual, so you can see, oh, okay, this for loop had 1, 2, 3, 4.
This is amazing. So many people are listening in the chat. What is this node? Wow. Oh my god, this would be so awesome for a randomizing objects effect. People are very surprised that these nodes exist. So go investigate our documentation. Go take a deep look. There's a lot of nodes. I'm always surprised by the nodes that are existing. And August, I keep noticing your bald head. Every time I look at it, it looks like you possess like great wisdom. Like you're the sorcerer, you know, from the
Yeah,
Marvel movie.
I can't confirm or deny that.
Mhm. Okay, I think
Uh,
we are out of time. Did you have
can I
anything more to
just
say?
Yeah, can I just add one more thing?
Yeah, of course.
Since we're kind of introducing these nodes a little bit, I should mention the set image and the get image. You might notice that they have a size and a pivot. I just wanted to point out in the screen image object, where it has a screen transform and an image, this version of image does not have a size and a pivot attached. That's because the size and the pivot are on the screen transform. But if you were to if you were to go to 3D and add an image, you'll notice that there is a size and a pivot because they're not attached to the 3D transform. So just a really good thing to note is just these nodes work for either image, the 3D image or the 2D image, but on the 3D image is the only place you're going to be able to manipulate the size and pivot. So just wanted to point that out. That was something that I was unsure of, and I was like figuring it out the other day, and I was like, oh, okay, I see.
Sounds good. Mike Black Hat says this could be used to create an animation like smoke. That's a really creative idea.
Yeah, yeah.
That's awesome. Thank you for the suggestion. Joe also mentions you can use a constant loop to animate something spinning around by fluctuating those transparencies. That's another awesome idea. So like it goes around and round, so it keeps becoming like the one that has the highest opacity like keeps going around and it looks like something's like the loading screen or something's going around. That's a fantastic idea, Joe. I love that. Joseph mentions August embracing his inner Professor X. Yes, Grace, you can find this video in our YouTube channel later. Okay, we are going to end here, but thank you everyone for coming. As always, it's extremely lovely having you all. Goodbye, Professor X August. Again, with our copyright free, I will sing out our what's that when you're leaving? Extro? No.
Outro.
Outro. Why am I so dumb today? My brain's not working. Okay. Goodbye, everyone. Have a nice day. See you again next week, same time. Good morning, USA. I got a feeling that it's gonna be a wonderful day. The sun in the sky has a smile on his face and is shining its flag to the American race. For those of you who don't know, this is the title song from American Dad, I think. I don't have favoritism towards America. It's always sent to say, good morning, USA.